Hello, my name is Bruno Vierens. I'm working at TMS Software, and today it's my pleasure to present you our components for interacting with Google Maps for Delfy, VCL, and FMX apps. In this presentation, I will first give you an introduction on using Google Maps in Delfy applications. I'll give you a brief overview of the architecture of our Google Mapping components. We will have a look at the different map options. Then we will write some code to programmatically control the positioning within your map and add markers to the map. We'll have a look at performing geocoding and reverse geocoding. We'll explore the directions options to calculate roads from point A to B. And finally, we'll round up with interactions with GPX files and GeoJSON files. Our Google Mapping controls are about programmatic control of Google Maps via Delfy code. The Google Maps provide a wide range of geographical functions represented in a map. And all this can be controlled from your Delfy application via our Google Mapping components. These components are available for VCL Windows applications, Win32 and Win64. They are also available for all platform targets within FireMonkey applications. So these Google Mapping controls can be used for Windows, macOS, Android, and iOS apps. And finally, we also have a version for intraweb, meaning that you can also programmatically control Google Maps from your intraweb web applications. In a nutshell, it's a collection of easy-to-use Delfy classes with its typical properties, methods, event that allow you to interact with Google Maps with no knowledge of JavaScript required. The Google Mapping API has a fairly liberal free use, and you need a key. Whether you use it for free or not, you need a key to use the Google Mapping functionality. We can have a look here to see where you can get this key. So on this page on the Google website, you can find here the place where you can get an API key. And if we have a look at the use that is allowed for standard API use, which is the free use, and then the build use, you can see that you can have here 25,000 map loads per day with the free use. If we look at other functionality like the direction service, the elevation service, the geocoding service, you can see here that in the standard plan you can have 2,500 free requests per day. If your usage is above this number of requests, Google provides a premium plan that allows you to do up to 100,000 requests per day for these different APIs. When you are in the Google API console, you can request the keys for your various Google Mapping functions, like the Google Maps geolocation API, the Google Maps JavaScript API, and different other Google APIs. For Google Map component, we will need the Google Maps JavaScript API. And for our geocoding and reverse geocoding, we will need another API key, the API key for Google Maps geolocation. So this is the place where you can request these keys. Coming back to the Google Mapping controls, let's have a brief look at the architecture of this control. Our Google Maps control is all based on a web browser control, where we instruct this web browser to navigate to this URL https maps.google.com. And the interaction with the Google Maps is done via the injection of JavaScript in this browser control, and also mapping web browser JavaScript events to Delfy events. We have separate non-visual components for accessing the Google geocoding and reverse geocoding APIs. There are different map options, and so we will first have a look at these map options. We can have different map types, different views on the map. We can enable traffic view, street view, we can control the language, and we can also programmatically control whether various mapping controls appear on the map or not. It's time to have a look at Delfy and have a look around on this Google Maps control and its various options. So here we are in Delfy, and we will use a VCL application to demonstrate the functions of our Google Mapping components. We could actually do exactly the same in a FireMonkey application. We add our VCL version of the Google Mapping control on the form, and actually what we see right now is a web browser that is blank because our control only navigates to Google Maps at runtime. The first thing to do is configure the API key, the Google Maps JavaScript API key. I have added these keys, the private keys actually, that I have in this include file via constants defined in the include file. And so I can write something like this: API key equals map API key, which is the name of the constant that holds my private Google Maps JavaScript API key. And that means that we are ready to go to launch our application. And we see that on startup, we see by default a normal view of Paris. And here we see the zoom control, street view control, and here we see the control that allows us to switch between a map view and satellite view. The default location of our Google Maps control here is Paris, and this is configured under map options under default latitude and longitude. All coordinates in Google Maps are defined in latitude and longitude, and this happens to be the values for Paris. If I want to position my map on another place, Google can also help us find the longitude and latitude of other places. We only actually need to do a search longitude, latitude, and we can, for example, look up London. And as you can see, it displays our longitude and latitude for London. And so I can easily copy and paste these values and make the map navigate to London by default. If I launch my application now, you can see that it has initialized on London by default. Let's have a further look at some of the map options. I can enable here, for example, traffic display. And with this option enabled, we can actually see the current traffic status in London, where green is that traffic is okay, red is that there is busy traffic. Here I can, for example, control that I will want to launch or set my map in satellite view by default, and this results in a satellite view of London. Finally, I also want to give you a look at the control options, which are under this property control options. And here you have configuration for different controls on the map. For example, I referred to the street view control. So you can make this control, first of all, visible or not on the map. And you can control the position of this street view control in various places on the map. The same applies for zoom. So the zooming can be enabled or disabled, and here you can determine if it's visible or not and where to show our zoom control. The map type control, which is by default displayed in the top right corner, can also be positioned at another place or can be disabled or not. We can also programmatically control the zoom level, for example. So if we want to zoom in more on London, we can increase here the zoom level under map options, and that gives us the following results. A more detailed view of London. So that was the first part of our demo where we showed some options for what you can see on the Google Maps control. Let's move to the second part where we will now show you how you can programmatically pan into the map, how you can programmatically zoom on a specific area in the map, and how you can programmatically add markers. And so let's move back to Delfy. And let's work further on our application, and I will add two buttons on our form, buttons from where I will first of all pan, and for the second button I will perform a zoom function. Here I will add code that will make the map pan to the city of Hanover. And here I will add code to zoom on the area of Cologne to Hanover in Germany also. So let's add the code behind this event. And we use here the map pan to function, where we need to specify the latitude and longitude of where we want to pan to. And we will also use Google to look up the longitude and latitude, in this case, of the city of Hanover. Let's paste these values from our Google results, like this. And that should be sufficient to make our map pan from London, the initial view that is on London, and make it pan to Hanover. And now the second button. In our second button click handler, we will add the code to make the map zoom. And that is something that we can do with the map zoom to function. And the zoom to function takes a bounce property. The bounce property is of the type tBounce, which is a class, so we need to create an instance of that class. And for these bounds we can control the northeast coordinate, which is also expressed in longitudes and latitudes, like this. And so we have also the southwest properties, longitude, and so the northeast will in this case be Hanover. So we can immediately copy and paste these values. And then of course I need to look up the longitude and latitude of the city of Cologne, which is this here. I can copy and paste these values again. Like this, and pass this as a parameter to my map zoom to function. And of course I need to free the instance of the bounds that I created. And let's have a look at what this code will be doing. Initial view is again London, and now I will make it zoom to the area of Cologne, Hanover, and we can indeed see here Hanover and Cologne, which is here. So we have the entire area of Hanover to Cologne on our map. Next, I will show you how you can add markers on the map. And I will do this from the onMapClick event. Here we have the various events of our Google Maps control. We have an onMapClick event, onMap double click, but in this case we will use the onMapClick event. And as you can see in the event handler signature, we have the latitude and longitude of where the click on the map happened. And so adding a marker at this position is as easy as adding a marker to the markers collection. And so here we can immediately pass the latitude and longitude event parameters. If I run this application, pan to Hanover, and I can add markers at various positions in Hanover in this case. I can also change various options of my marker, and if we have a look at the various parameters, let's make them appear. Okay, let's a little bit careful, and here I can set the title for my marker. I will not use a different icon. I can make my marker draggable. I can make it visible or not. What more do we have? We can make it clickable or not. So if I click my marker, it will trigger an onMarker click event. I can add some animation when I add the marker on the map, and finally I can also add some marker color. So I do not have the default red, but for example I specify green and I see a green marker. So to have this in effect, I will now add some marker on London, and you can see that now such a green marker is added on my map. And that is it for the second part of this demo about position control and adding markers. So let's move to the third part of the demo, the part about geocoding, reverse geocoding, and we will use the non-visual components TWeb, Gmaps, Geocoding, TWeb, Gmaps, reverse geocoding for this. And I will also introduce a VCL specific component, the TWeb Gmaps lookup edit. And so let's move back to Delphi. And first of all, let's add our non-visual components for geocoding and reverse geocoding on the form. And this is the reverse geocoding control. And the first thing that I will do is specify the API keys as these geocoding components. Reverse geocoding use the Google geolocation API key. And this is defined by a constant in my inc file geocode key. And the same thing for my reverse geocoding components. I also initialize the key to geocode key. Now I will add my web Gmaps lookup edit control. This is the edit control, and so this is an edit control that can automatically perform lookup editing while I key in an address. I just need to enable the lookup function. And also for this component, I need to specify the API key, like this. So what I will do now is I will type in an address, and then I will let my map pan to the location of this address. And so I add a button, and let's add the Go caption. And so when I have typed in my address, I will perform the geocoding by letting the address the value of my WebGMaps lookup edit control, text, and then I will launch WebGMaps geocoding.launch geocoding. So when this result is successful, the coordinate found for my address is returned via WebGMaps geocoding.result latitude and the result longitude. And I will use this to make my map pan to this specific coordinate. Like this, result longitude. Okay. And let's see what happens now when I execute this. We are in London, and I can type in, and as I type, you can see that it performs auto-completion. So I can let it auto-complete now to the Champs-Élysées in Paris, France. And I can ask go. And when it performed its lookup, you can see that now I moved this way from London to Paris. And if I zoom in, you will see that we arrive in the area of the Champs-Élysées. I can do the reverse now. And the reverse geocoding, I will trigger that from the map click. I will not add a marker this time, but I will launch the reverse geocoding based on the coordinate where I clicked on the map. And I set here the longitude and latitude to the parameters of my map click, and the same for latitude. Like this. And then I launch the reverse geocoding. Like this. And when there is a result, I can actually show the address found on my caption of the form. I show the result address dot formatted address, which is the address that it finds at this specific location. So let's start the application again, and let's zoom in a little bit on London. And I can, for example, click here on this road. It should perform the geo reverse coding, and you can see here on the caption of the form that it has shown the street where I clicked. So this is the last street that I clicked. So as I click on my map, it will show us exactly on the address where I clicked. And so this is how easy you can use these geocoding and reverse geocoding functions. And as we get along in this demo, it becomes more interesting all the time. And now in this new part, we will be looking at getting and rendering directions in the Google Mapping control. So we will have a look at calculating routes from point A to B and showing these in the map. Let's move to Delfy, to our application that we are building here, and we will be adding another lookup edit control, as we will ask from Google Maps to navigate from one address to another address. And so I will add a button from where we'll trigger that. A function that calculates the road. And what I will do is pre-fill the first lookup edit with the address of our office. Like this. What I also need to do is set the API key of our second lookup edit control, otherwise it won't perform the lookup editing. And then we will add the code that will calculate the direction and render the direction from the two addresses that I specify. So here in this case, from our office address to another address. And so what I will first do is use the render directions API call. And so this lets us specify an origin and a destination, which are in this case the addresses of from where to where we want to navigate, or we can also specify the origin and destination in terms of longitude and latitude coordinates if we do not have an address. So in this case, we will be using the edit controls addresses, and this will be sufficient to let the route calculated and displayed in Google Maps. And so this is our office address, and we will ask how we can navigate best to the Champs-Élysées in Paris. We ask to calculate the road, and here we can see the road that it calculated from our office to the Champs-Élysées in Paris. We can do a more detailed calculation of this road, and we will do it in the following way. We will add a list box control to our form. This is the list box. And I will also add a web GMaps directions list. The web GMaps directions list is a special list control that will show the detailed step-by-step route that was calculated by Google, and it will display it in HTML formatted text. So this will probably be best suited. And so I will now add, instead of rendering the directions directly, I will now perform the method to get the directions from, again, my origin and destination address. By calling the getDirections function, WebGMaps will now fill the WebGMaps directions collection, which is a collection of possible roads that it found from A to B. And what I will do is I will fill my list box items with the possible roads that it finds. And I can get the possible directions as a string list, and here I can specify that I want it in US metric units. So now we will see the roads that it finds for traveling from our office to the Champs-Élysées in Paris. And you can see that it found one road here right now, and it adds this road to this list box. And now let's make the detailed description of this road visible in my direction list control. And I can do this this way with the fill direction list method. And here I can specify my direction list control items, and what I add is the first route in my directions that it finds. That's not enough. Now, as I disabled the render directions call, I still won't see my road on the map, so I need to do this programmatically if I do the get directions call. And I can now render the road as a polyline in the following way. I retrieve the road from my directions collection, and I retrieve it as a first item from this collection. And now I can call polylines.add, and this function has different parameters. I can add a polyline in the following way. I make it non-clickable, non-editable, not geodesic, no symbols collection to it, and the path can be found via road.polyline.path. There are a few extra parameters, like the color. I specify the color, the opacity of the polyline, the width. Let's make it wide enough to be visible. I set it to true, and I can also add a z-index of my polyline. So first thing is filling the direction list, then obtaining the road, and then add that as a polyline to the web Gmaps control. Let's see this in action. Maybe I can first show the area of Paris like this. And now I enter the destination address, and I have it calculate the road, and as you can see, it finds this road, and here you have a detailed description of all the steps along your way to travel to the Champs-Élysées in Paris. So from the start address to this destination address, and the road is actually displayed here on the map. And this brings us to the last part of this presentation, a part about dealing with GPX files and GeoJSON files. We will show you how you can import and export GPX files with the methods load GPS route and save path to GPS route. And this for the GPX files, and we can also import GeoJSON files. GeoJSON Files is a standard file format that deals with saving geometries in JSON format, geometries that you can load into Google Maps via the Load GeoJSON Polyline or Load GeoJSON Polygon. And so, first of all, I want to show you here the source of the GeoJSON specification at geojson.org. And so you can see that this is about JSON file format, and this JSON contains the full geometry, lines, polygons of objects that you can display at specific locations in Google Maps. So let's move to Delfy. And the first thing that I will actually show you is how you can export a calculated route as a GPX file. And for example, you can load these GPX files in other navigation systems. So we do this by calling web-gmaps, save path to GPS routes. And the path is obtained via the polyline.path from the route. And the second parameter is the location where we can save this file. And we will save it in this folder. And we save it as the file office2paris.gpx. So if we run this application, and again instructed to calculate the route to Champs-Élysées in Paris, this way it should now have created the file here this file office2paris.gpx. That this file contains the route, we can verify that, and a useful website to verify that is the maplorer.com website. So if I select car and select choose file, I can now go and pick this file office2paris.gpx and view the profile of that file. And as you can see, it has here is now showing the route that was calculated by our Google Maps control and exported to a GPX file. In the same way, we can also load GPX files in our control. Here I have prepared a GPX file that contains the route along the river Mosel in Germany. So let's have a look now at our Google Maps control and add some piece of code that will load this GPX file in our Google Maps control. And so let's add a bit of code. Load Mosel route GPX, and this is not much more than adding the code web-gmaps load GPS routes. I have a number of parameters. The first parameter is the file itself, which is here under projects web-gmaps Mosel.gpx, and I have a few options. I can specify the color. Let's use red again to be very good visible. Let's make it a little bit wider than default, 4 pixels wide. And I have an additional parameter that I can use to automatically zoom my map control to the area where the route is displayed. And so I will enable this and set this parameter to true. And so let's see this also in action. We are still at London. Now we load this Mosul route, and as you can see, this is a road from Trier to almost Koblenz. And if we zoom in, you can see that this is a road along the river Mosel. And so this is a file from a navigation system in the format, the GPX format, that is loaded here in our Google Maps control. Now, let's round up with GeoJSON files. As I explained, these are files that contain geometries at specific coordinates, longitudes and latitudes, and these geometries can be displayed on top of a map in Google Maps via our load from GeoJSON method. And so what I will do now is add another button and load GeoJSON file. And I can do that by adding the method load from GeoJSON polygon. And here I can specify the file name. I have prepared a couple of GeoJSON files, and they are actually here in this folder for GeoJSON files, and these are files that I found on the internet and contain the administrative information, in this case from the country Belgium. And let's open this file to see what geometry it holds. In this folder it is located. Let's copy and paste the file name. Like this, and let's see the result of loading that file. Now we can not only see that it loaded the entire area of Belgium as a complex geometry, including here the territorial waters of Belgium, but it also automatically zoomed in or put the zoom position of the map in such a way that the entire geometry is visible. Now, for curiosity, let's open the other GeoJSON files. And here, in this second case, we can now see actually three different geometries, which are the three administrative areas of Belgium, being the Dutch-speaking part Flanders, the French-speaking part Wallonia, and the common area Brussels, the administrative area of Brussels, that has both French and Dutch-speaking parts. I'm sure you are curious what the next GeoJSON file is about. That one contains even more geometries, and here we can see the different provinces of Belgium, and if we hover over these different provinces, we can actually see the name of the province. This information is retrieved from the GeoJSON file and is automatically added as a hint when I hover over these geometries. And if I go administratively one more level deeper in detail, I finally come into the smaller areas in Belgium, the smaller administrative areas in Belgium. And here we can now see the country divided up in numerous small areas. And here, for example, we can see the area of Bruges, the area of Ghent, the area of Antwerp, etc. All this information was stored in this standard GeoJSON file format, and you can find numerous places on the internet where all kinds of administrative information, for example, also the states of United States of America, countries of the world, all this information is available in GeoJSON format and can be used to indicate specific areas, for example, on your Google Maps and to interact with it. And this rounds up our demo for our Google Maps controls. It's important to note that everything that I showed here today in this demonstration was for the ease of use, all done in a VCL application, but the same could have been done from a FireMonkey application. To round up some more interesting links, here is the page where you can find our VCL component, the VCL Web Gmaps control. Here you can find the FireMonkey version of our Web Gmaps control, also the IntraWeb version, and finally there is this place where you can find more videos. I will navigate to that page to show you. If you go on our website to support, then videos, you land on our Google YouTube video channel, and here you can see several more demos with details on specific topics of Web Gmaps, and you can find these videos on Web Gmaps both in German audio and English audio here. So I invite you to also have a look at these other video demos. And that brings us to the Q&A part of this webinar. So if you have any questions, feel free to ask and I'll be happy to answer them for you. Thank you.
Thank you, Bruno, for that great presentation, for these great Google Map components. If anybody has any questions, go ahead and put them in the question panel here and we'll get them answered for you. Bruno's already been answering a few of them, but we'll go through these and any other ones you might have and get them all answered for you. So you talked about Delfy, but this also works all C++ Builder, FireMonkey, VCL, etc., right?
Yeah, the components, we offer support for VCL, for FMX, and then both platforms for Delfy and C++.
Do you also have support for OpenStreetMap, or is it only Google Maps?
This component is specifically targeted and uses the Google Maps API, but we have another component which is specifically for OpenStreetMaps in that case.
Probably a different set of functionality when you get down to the details on those, so it makes sense.
That's correct. The APIs are different, so the components can only expose what the APIs offer.
Does it contain the area of the regions so you can calculate the size of those regions that you're putting in?
No, so there is, as far as I know, not a Google API function to retrieve the area of a polygon, and there's also not a built-in function to do that for you. So all the coordinates of the polygon are available, accessible. So I think with some math you can calculate that, but so you actually have to perform that calculation at this time yourself, based on the polygon coordinates.
So really the components are wrappers around the Google API. So if it's not exposed to the Google Maps API, it's not something that you do. Is that accurate?
Well, for example, importing GPX files, importing GeoJSON files is not something that is part of a Google API. So what we do in this case is we read these files, we decode them, and we convert them into polygons. And polygon or polylines are part of the Google API. So it's not just strictly using or exposing what the Google API exposes. It's just using what the API exposes to do more than that. But in the particular case of area calculation, this is at this point not something that we do in the component, and as far as I know, not something that the API exposes. What the API exposes, and I know it exposes, is, for example, distance calculation between 2 points. And so I think if you combine what's available, you can achieve area calculation. Maybe it's interesting to add that in a future update of the component, but at this time it's not built in.
How about calculating a route for several different points?
That can be done. Actually, can be done in 2 ways. First of all, you need to know that the Google Directions API, the free version, supports to specify up to 8 waypoints. The premium one can go up to 23 waypoints that you can specify. So that's what's available out of the box. But in addition to that, we have added a capability where you can build up a route by combining roads, separately calculated roads. So in this case, for example, you can connect up to an unlimited number of points in your road by actually doing multiple requests to the Directions API and avoiding that waypoint limit that Google Maps API has.
Cool. So when you're doing that, you have to know which ones you wanted to have them in order, I guess. Well, they still would. Okay, yeah, it makes sense. That's actually cool. Very cool.
There is actually a demo included where you can just click on the map, and as you click on the map, it builds up the road from point to point. So you can click and have as many points as you want.
So if you have several points and you want to find the best route, I guess the traveling salesman problem, right? How it's the best way to visit each of these points. Is that something it supports?
When you use the built-in Google waypoints that offers in its API, then this is what Google performs. If we talk about the step-by-step building up that road, then that is just building it up step by step, and it's not taking in account the points that you have not added yet at that point. It's just a step-by-step approach. All
right. How about, is there support for GIS shapefiles?
No. So at this moment we support KLM files and GeoJSON files.
Well, fantastic, Bruno. Thanks for this great presentation and for all the work you do with your Google Map components and all the other fantastic components TMS has. I'm a big fan of TMS. Got a lot of great components over there. So.
Thanks a lot, Jim.
Yes. Absolutely. A lot of positive feedback here in the questions as well. So thank you very much.
Thanks a lot, Jim.
Yep. Hello. Thank you so much, Bruno, for that great presentation. There are a few questions already in the question panel here. We'll go ahead and get those answered. If there's any other questions, go ahead and put them into the question window there, and we'll go through them here and get them answered for you. Are you there, Bruno?
Yes, I'm here. Do you hear me? Hello?
Yeah,
Can you
I hear
hear
you
me?
just fine. Yep. I hear you fine.
Okay, thank you.
Let's see here. The Google limits, do they appear per instance of the application, per device, or how are the limits applied?
It's per API key. So if you create an application with your specific API key, each instance of your application running with that API key will count for accesses that will determine if you are under the free plan or you need to go to the premium plan.
Okay, so you go to the premium plan, then you get plenty of your limits go way up. Then that makes sense. How clustering functions? It would appear you have to determine the location of a cluster rather than having the component suggest where you have clusters of elements of data. Is that correct?
That's a good question. As far as I know, it's location-based, but there is a demo specifically showing clustering functionality, but to be 100% sure, I have to check whether it's automatically location-based or you have to do it programmatically yourself. So that's something I need to check to be 100% sure I give a correct answer.
Okay, makes sense. I totally understand that. I was having a conversation with Nick Hodge the other day. Like, you know what? Everything we work with, there's just so much of it that you really have to look everything up. It seems like anymore because you just can't assume that you keep it all in your brain anymore. There's too much to do.
That's correct, yes.
So Ricardo's asking, can you put the default coordinates in at design time or runtime?
You can do both actually. So as you can see, out of the box, the default longitude and latitude is configured to be Paris. But if you change that at design time to any other coordinate, that will work fine. Alternatively, you can change it at runtime. The only thing that is important is that you do that before you call launch of the web Gmaps control, because it is that default longitude and latitude that is picked up to steer the map when you launch the map. If the map is already launched and you want to focus on another area, you can use the map pan2 function that will move the map to a new longitude and latitude.
Okay. And I see you're saying that it works with XC and newer, as far as what versions of Delphi it works with because of the JSON procedures. And then as far as, there's a couple questions here around licensing of the Google Maps API, and that's something they probably really need to contact Google to get the correct answers for, but generally speaking, it's like you need the commercial API to actually do a product with it, but otherwise you can use the free one for kind of exploring purposes, it sounds like. How would I capture and feed the current location of an iOS Android phone into Get Directions? So there's the location component you can use that comes with Delphi and C++ Builder. That you can just use that, and then has a location change event that you can put in to capture that. One thing I will point out though about that is that the you kind of have to do a little bit of logic in there because the GPS will trigger change events if you don't tweak it, saying that you've moved when you really haven't moved, and so you have a little bit of a wiggle, and so you kind of have to almost filter that down so that you're not getting too much movement, because it will produce, you have to understand the difference between the different latitude and longitudes when it gives out how many decimal points to how many meters or feet that is an actual movement. So it's actually kind of interesting to start playing with. I learned a lot about latitude and longitude when I was doing that. Is it possible with the Google Maps API to calculate if two coordinates are within a certain distance to each other, such as proximity analysis or geospatial analysis?
Yes, there is a distance function that takes two longitude and latitudes and can give you the distance.
Fantastic. And that, I'm assuming that uses like Earth curvature and stuff like that into the account for the distances, or do you know?
There is a parameter that controls what type of distance that you want it to return. I know that there is a geodesic that you can specify, for example, to get the geodesic versus the normal distance. So with some parameter you can specify that.
Okay. Are road types like normal roads, motorways, city accessible roads, international routes visible or accessible?
Yes, so in the demo I used render directions or get directions method, but there are overloads of that method that have many more parameters, and one of these parameters is to define what you're using by car or by bike, etc. If you want to avoid tollways, for example, is also a parameter that is available in overloads of this get directions call.
And now you mentioned, I think you mentioned one tool for producing the GeoJSON files. Is there a list of tools someplace that people can use for that, or what do you recommend as far as how to get started with GeoJSON files?
At this moment, I do not know out of the top of my head a tool that can produce these files. We have obtained a number of files for testing from various instances, like for example the detailed country information I showed about Belgium is from I don't know from the top of my head, but some geographical institute that makes these files available for free. There's also on GitHub, that's a free project where you get GeoJSON files. For example, all the states from the United States are in there, all countries worldwide are in there. So there are various sources to produce these files yourself. As I said, I do not know a tool out of the top of my head, but we have it actually on our feature request list, so that's something that we want to provide in the future, in a future version of WebGMaps, that you can simply draw on the map and produce from that a GeoJSON file.
Okay, great. There's a request here for a link to the slides. Can you, if you provide that, we'll make sure and include that in the replay link when the email goes out as well. So if you could put those online, like SlideShare, or just send them to me and I can share them, or whatever works best.
I should send the link to you then, Jim, I suppose?
Yes, that would work.
Okay.
If you have it now, you can put it in the chat window if you have it now. But otherwise, yeah, send it to me and I'll make an email out to everybody.
I send it to you, yes.
Okay. Do the TMS components contain functionality to handle route optimization when giving a list of locations? So the
route calculations is fully dependent on the calculations that actually Google performs. And so if you use the get directions call, as I explained, there are a number of parameters that control the type of route that you want Google to return. And Google can return multiple suggested routes, and so you can, this is captured by our component and exposed as a collection of possible routes that Google returns, and you can go through all the details of these routes, and actually it's a collection of leg by leg how the route is composed. And from that you can, let's say, apply your own logic to determine what route is the best.
Questions here about, do these work with C++ Builder as well, or are they Delphi only?
Both Delphi and C++ Builder.
All right, great. And I see they're $95 euro for the single developer license. Lots of good feedback here. Thank you so much. Actually, I'll chime in here and say this was a great presentation. I enjoyed it as well, and I'm a big fan of your components. I think you're always has so many neat things going on. I wish I had time to play with all of them. You know, especially from multi-device development, TMS is like one of those ones you have to have in your toolbox to get so much more done. Is the source code for the demos available?
For the demo of today, I try to focus on live coding everything step by step, but I can of course share the results. Not that it's that the application is very clean in terms of user interface, etc. I try to focus on making it clear that you can do a lot of things in a really simple way. But I see no problem in sharing the code that I did for this live coding today. So I suggest, Jim, that I send this code along with the PowerPoint itself.
Okay, sounds good. Usually your components ship with quite a few good samples with them as well. There's probably a number of these samples are built in, or similar samples are built into the, or come with the components.
Actually, there are many more demos than the functionality that I tried to cover in this presentation today. For example, I did not mention the polyline polygon drawing that is possible. I did not mention custom marker images that you can use on your map, that you can also use KML files to superimpose on your map. So actually there is much more in the component than I can cover in 1 hour session, but these are shown, these features are shown in several demos that are included with the components.
Okay, great. So when you're asking about adding raster images on top of the image result map, it sounds like that's something you just mentioned is possible?
Yes, you can draw lines, circles, put some text, polylines. So yeah, all this is available. Actually, the drawing of lines and circles is shown in our directions demo that is included. So the directions demo, I only showed in this live session the basics of getting directions, but in the directions demo that is included with the product, we draw circles around the start and end address of the direction.
So there's a few more questions here about route optimization. It sounds like, if I'm understanding correctly, that that's done by Google, but you can obtain the route information and work with it from there as well, though, right?
You actually get every part of the route that Google calculates. You get that as a result, and so a route consists of a number of legs. And so for each leg you get the information from what coordinate to what coordinate it is and what the distance is for each part. So this detailed information is all returned via the directions collection that is filled when you call get directions.
Okay. If there's more than one polyline on the map, is it possible to delete one of them by ID?
Yes, polylines, polygons can all be accessed by ID, so you can change attributes or remove, add polylines, polygons, circles, etc. by ID. Actually, you get a collection of these polylines, and you can manipulate this collection in code.
Now, I know that typically when you buy a TMS components, that includes, I think, what is it, like a year's worth of updates or like till next major version or something like that? Is that correct?
For the Google Maps components, we offer a full version cycle of free updates and free support. That means that, let me quickly look that up. Right now we are at version 2.8, so that means that everything between now and the moment we have 3.8 is free and free updates and free support. And in terms of time, this will be definitely well over 1 year, I think perhaps 2 years that you get free update and free support.
Okay. And so if Google updates their APIs, they typically are pretty good about keeping the old APIs working for a little while, but people would need to update the TMS components if there was something significant that changed over time. Is that correct?
Exactly. That's indeed an important responsibility that we have to take on.
Should we expect to be able to have multiple instances of the FireMonkey Gmaps operational on Win32 anytime soon? It says currently it seems to only support one at a time.
Can you repeat the question, Jim, because I did not fully understand.
So the question is if you could have multiple instances of the FireMonkey Google Maps component Win32 applications. So previously we were only able to have one at a time is what Anthony's saying.
That's a good question. That's a good question. If you have 2 minutes, I can test it to be 100% sure. It's a matter, actually technically, this is a T-web browser instance on your form. So technically, I would see not immediately an issue that if you can put 2 web browsers on the form and navigate to some point that you could also do that with web Gmaps. So
thank you very much, Bruno, for this great presentation. I'm going to make Bruno a panelist now. I'm going to unmute you, Bruno. Let me know if you can hear me.
yes, I can hear you, Serena.
Hi, Bruno. Well, thank you very much again for this great presentation. And during the presentation, we received some questions. And the first question here is, are these components available in C++ Builder as well? Should I install extra packages to have them? Currently, I do have them in my C++ Builder.
Components support C++ Builder, so if you install the components, they should show up on the component palette, depending if you installed the VCL version or the FMX version in FMX projects or VCL projects.
And what versions of RAD Studio do the components support?
We start from Delfy XE and C++ Builder XE, and the main reason for that is that internally we need to use JSON, and we use the JSON libraries that come with Delfy. So there are actually also no extras to install along with these components. They are on their own, no other dependencies.
Great. And if you have any other questions for all the attendees of the webinar, please enter them in the questions pane on the GoToWebinar control panel. Now there's another question here. Is there a function to translate zip or postcodes to long/lat?
We have these classes for geocoding and geo-reverse coding. But I'm not sure. I do know that if you enter a partial address, like for example Eiffel Tower, Paris, it will return the longitude and latitude for that specific place. I'm just not sure if you just enter a zip code, if Google is smart enough to associate that with the city and return the longitude and latitude. That is something that I should try out.
Okay, thank you. And another one. Here it says, well done. Any hints for capturing and using GPS data such as current location?
Actually, if you are on a mobile device, for example, you can use the built-in Delfy component on FMX to capture the device location with the T-location component. That component returns the longitude and latitude, and you can thus use the map pan2 function to automatically position the map at the position of the mobile device. We also have in our TMS cloud pack, we have a component that will also try to retrieve the location of a machine, a desktop machine in that case, based on several criteria. So it's basically based on IP address conversion to geolocation, and that's also something that can be used to steer your map to the position where your desktop or laptop computer is.
Great. And do the map components support the addition of like custom overlay graphics or pins to mark a location or multiple locations?
Yes. So I showed in this demo only the standard Google markers, but you can also use your custom markers, and basically this is just a reference to, for example, a PNG file that you can use to use any marker that you want. In addition to that, there is also support for using KML files as an overlay, and so you can also add a reference to a KML file and it will overlay it on the map. There's actually also a demo on that included in these WebGMaps products, where we overlay the time zones, a KML file of time zones on Google Maps.
Great. Now here's another question, Bruno. What browser libraries does this component use on Windows to show GMaps? Internet Explorer or internal libraries?
In Windows, we use the IE ActiveX control, which is actually the same as the T web browser control that is included standard with Delfy.
Okay. Comment here from Jeff. I really like this webinar and I'm looking forward to the recording so I can review details again later. Thank you so much. I had no idea so much could be done with the GMaps API. Yeah, thank you very much, Jeff, for the feedback. I'm sure Bruno's happy to hear that. I totally agree. The components are very powerful, and this has been a great presentation. We have a couple more questions here. I tried before with Google Maps, but Google does not have zip code for all countries.
Okay. I write this down, and I will need to do some more detailed research if there are capabilities, and if so, how these can be somehow exposed, integrated.
Great. Now here's another question. What are the restrictions for using the API key in regards to number of lookups and search rate per second?
So I actually, in the beginning of the presentation, pointed at the page where Google describes what is permitted with the free API key and what is available for the premium users. And so if I remember well, for the most restrictive actually is the geocoding and reverse geocoding, where, if I remember correct, you have 2,500 accesses per day. For regular Google Maps JavaScript API requests, that's a lot more, but I do not remember at this moment the exact number, but everything is described on the page that I showed in the beginning of the presentation.
Okay. Are there any plans for a Bing component? A Bing Maps component?
there are no fixed plans for Bing. We know that a number of customers have requested something like that, but to be honest, the number of features in Google is so interesting, and versus the number of people who really want Bing support. So let's say that the balance for now is that we tend to favor the Google Maps.
Okay, another question. TMS also has components for OpenStreetMaps. Do those components work the same way and have the same functions?
No. So obviously for OpenStreetMaps, we can only use the functionality that is exposed by OpenStreetMaps. And at this point, Google provides many more features than OpenStreetMaps. So actually it's the provider of the service that mostly determines what our component can expose and what not.
Okay, and I think our last question here is there a way to get a spherical projection map?
As far as I know, there is no way to do that. And I would actually have to check if Google has built in some kind of support or feature for that. So I first need to check if somehow this is achievable by the Google Maps API. And on that condition, it's a matter of investigating if we can add support in the component.
Okay, well, Colin says very impressive. Well done, Bruno.
Thanks. Thanks, Colin.
Thank you, everyone, for joining. That concludes the session. Have a great day. Thank you. Bye-bye.
Thank you. Bye-bye.